Shall we start, ma'am?
Yes, Ashisha. We can start.
Okay. Hello, everyone. Present here virtually. I am Pallavi here, and I welcome you all for today's session, which is titled as Introduction to PLS-SEM 3.0. And presenting this session, we have with us our today's expert, Muskan Khan ma'am. Dr. Muskan Khan ma'am. Dr. Muskan Khan, working as an assistant professor in GL Bajaj Institute of Technology and Management. Greater Noida, she has 9-year experience in academics and 5-year experience in the field of research. She has completed her PhD in management in the year 2020 from Dr. APJ Abdul Kalam Technical University, Lucknow. She has completed her post-graduation with the degree of MBA with the specialization in human resources, management and marketing. She has published more than 9 research papers in preferred national and international journals of UGC and Scopus. She has presented paper in IIM Bangalore, also attended national and international seminars and conference. She has expertise in quantitative data analysis using statistical package for social sciences, PLS-SEM 3.0, Process Macro, R Python and MS Excel along with the expertise in qualitative analysis using NVIVO was where her areas of interest are human resources management or organizational behavior, strategic management and research methodology. Without wasting much time, I am welcome to Dr. Muskan Khan ma'am. You may start now, ma'am.
Thank you so much. Thank you so much. First of all, I would like to congratulate the entire team of the Research Circle to organize such a great event and to introduce such a great platform where the researchers from the various backgrounds could discuss their viewpoints and could have some knowledge sharing also. So congratulations, Research Circle team. So here, in this particular session, what I'm trying to do is to introduce you people with the introduction to the PLS-SEM. In this particular session, you will be able to know what is PLS-SEM, what is structural equation modeling, what is the basic difference between the PLS-SEM and other covariances SEM, what are the major features of PLS-SEM, why there's a need to use PLS-SEM, and where we can apply this particular PLS-SEM, because most of the time I have seen the researchers having the doubt like whether to apply PLS-SEM or another covariance analysis. So here I'm trying to take out those thoughts of the researchers and try to make this PPT which introduce or provide some introduction, some insights about the PLS-SEM. Previously, what happened? Previously, statistical analysis was done with the help of the SPSS, with the help of the Excel. So now there is a time when people are using the structural equation modeling. Here, what is the advantage? Why there's a need to use this particular software? We all come to know. Here, I would also request the audience to pen down their queries, which I could address at the end of the session. My slide is visible, I think. PPT is visible to all?
Okay. Yes, ma'am.
Okay, thank you. Inside this presentation, you will be able to know the introduction of the structural equation modeling, the different types of SEM, that is structural equation modeling, characteristics of PLS-SEM 3.0. Nowadays, we have PLS-SEM 4 also. Rule of thumb for choosing between the PLS-SEM and the CB-SEM, that is covariance-based structural equation modeling. What are the certain considerations which should be kept in the mind when we use the SEM? Data consideration when using the SEM, how to specify the path model, and what are the certain guidelines for preparing the PLS path model. Basically, what is structural equation modeling? Why there's a need to use the structural equation modeling? Statistical analysis is the essential tool when we are using or when we are applying it in a social research, social science researchers, more than a century. Researchers initially relied on the univariate and the bivariate analysis to understand the data and the relationship. Previously, what happened, we relied on the univariate and bivariate analysis. We use Excel, we use SPSS to interpret the relationship between different variables or to understand the relationship among the various like variables. But here, when we use the structural equation modeling, we are able to understand the strength of the relationship between the x variable and the y variable. So to comprehend some more complex relationship associated with the current research direction, it is become very important to apply some sophisticated multivariate data analysis methods like PLS-SEM. We have MOS also. Both are the tests which we could apply when we are applying or when we are going with some analysis which is based on some model. Nextly, how we organize our multivariate methods. Firstly, before this PLS-SEM, we have first generation techniques, that is primary, exploratory, and primary confirmatory. So what is exploratory and confirmatory now? Exploratory research is the research when we are trying to explore something new, when we are trying to explore some relationship, some theory with the help of certain variables. Confirmatory means when we have some model, when we have some theories, and we are trying to analyze those particular theories into a new context. So before the PLS-SEM, we have first generation techniques in which we are trying to use when we are exploring some new research. We go with the cluster analysis, we go with the factor analysis, we go with the multi-dimensional scaling. In order to confirm our new research, in order to confirm some basic theories, we go with the analysis of the variance, we go with the logical regression, we go with the multiple regression. But nowadays, people or the researchers are using second generation techniques. That is, if we are trying to explore some new theories, we have to use PLS-SEM. Or if we are trying to confirm some theories, for an example, we are having social exchange theory, we are having leaders membership exchange theory, we have stimulus theory. If we are taking the variables which are from these theories and we are trying to confirm their relationship, then we have to go towards the CB-SEM, that is covariance based SEM, including confirmatory factor analysis. But if we are trying to explore some new theory, or we are trying to we have hypothesis which explains new variables, like we have taken one variable from the exchange theory, we have taken second variable from the leadership members exchange theory, we have taken one variable from the stimulus theory. Then when we are trying to generate some new theory, we are trying to explore something new. When we are trying to explore something new with the set of the variables, we have to go with the PLS-SEM, that is also known as second generation techniques. Basically, we have two types of SEM, covariance based and PLS path modeling. So what is the basic differentiation between the covariance based SEM and the PLS path modeling SEM, that is PLS-SEM? This particular slide is very important because it differentiates the types of SEM. People have the confusion like whether to use PLS-SEM or to use the CB-SEM. So this slide, I hopefully clarify your doubt. That is primary use. Primarily, we use covariance based SEM when we are trying to confirm or to reject some theories. For an example, we have one theory, like we have your big five theory in the personality. If we are taking the big five theory and merging this particular theory with another theory, what we are trying to do, we are trying to confirm it, we are trying to accept, or we are trying to reject it. So in that case, you have to go with the covariance based analysis, that is CB-SEM. If we are trying to develop new theory or we are trying to explore our research with the help of the theory, we have taken few variables from different aspect and trying to make a new model or trying to explore something new with the help of that particular model, or we are trying to enhance some skills, measurement skills, we are trying to develop some theory. Then in that case, you have to go towards the PLS-SEM, that is PLS path modeling also. Estimation, when we are trying to determine how well the proposed theoretical model is set with the data. If I'm having certain set of data and I want to know that this particular set of data is determined with my model, then we have to go towards the CB-SEM. If we are trying to explain the variance between the independent variable and the dependent variable with the help of the model, then we have to choose PLS-SEM. When we talk about the data distribution, some like software has a rigidity that this number of sample is mandatory in order to run this particular software. But in the CB-SEM, we have to use the normal distribution data. When the data is normal distributed, when the data set has been removed with the outliers, we have outliers in the data set. Basically, what we do when we use SPSS, we try to remove that outliers to make our data normally distributed. We do that with the help of the SPSS. Like we remove the outliers from the data and we try to make our non-distributed data into a normal distribution phase. So when you have the normally distributed data, you can use CB-SEM. But in case you have non-normal distribution of the data, means the outliers are not removed from your data set, in that case you have to go towards the PLS-SEM. PLS-SEM generally makes no assumption about the data distribution. If your data is normally distributed or not normally distributed, you can easily use the PLS-SEM dataset or the PLS-SEM software. So these are the two type of SEM, that is structural equation modeling. First one is covariance based, second one is PLS path model based. What I suggest, depending upon the hypothesis, depending upon the objective of your study, depending upon the model you are trying to predict, you will choose the SEM. Like if you are trying to confirm some theories, you have the hypothesis which are helps to confirm some theories, you can go towards the CB-SEM. That is, you can use basically a mouse. But when you're trying to develop some theory, you have non-normal distribution of the data, you have some independent dependent variables, you have some mediation, you have some moderators, and you want to go easily with the data set, you can use the PLS-SEM. That is 3 or 4, whatever choice you have. These are the basic characteristics of the PLS-SEM. Like if I talk about PLS-SEM, this is particularly a software which helps you to make a particular model. It helps you to determine how your data set is equivalent to the model, how your model is good for the fitness of the research, your model is suitable for the research. So if you're trying to develop a new model or the theory with the new model, you can use PLS-SEM. This, if I talk about the data characteristics, the sample size, no identification issues with the small size. Like PLS-SEM can easily be run with the small sample sizes. But yes, there is a thumb rule which I'll tell you later. Generally, it achieves a high level of statistical power with a small. If you're having small size, there is no issue, but it should meet the threshold like a rule of the SEM, which I'll tell you later. Larger size, if you have larger size of the data, that the consistency, the reliability, the validity of this model would be increased. Distribution, as I already told you, it accepts the non-distributional data. PLS-SEM is non-parametric by default. Missing values, yes, of course, if your data set has some missing values, it is highly robust as long as your missing values are below the reasonable level. If the reasonable level is below the accepted threshold value, then the PLS-SEM could be done. Scale of measurement, like we have, when we prepare the data, we have data set, we have some measurement like scales. We have ordinal scale, we have nominal scales, we have Likert scale. So what sort of scale PLS-SEM accept? PLS-SEM basically accept the ordinal set of data, ordinal set of measurement scale. So there is some limitation. This is, yes, a limitation. If you're having the ordinal data, depending upon, like we have some variables, we have some items, we have using the Likert scale. In that case, PLS-SEM could be easily done. If you're taking, like if you have taken some demographic variables, like if you have taken some gender as a demographic variable, you have taken income as a demographic variable, you have taken like you can take number of children as a demographic variable, whatever demographic variable you have taken, that could be run in the case of the moderator or the mediator. Secondly, model characteristics. Yes, it handles with a model with a single item also. Whenever we prepare the variables, we have certain items, like 4 items with a variable. Like for an example, if I'm having the employee engagement as my variable and I'm using the Gallup scale, that is the measurement scale, I'm using Gallup's 12 questions for that. In that case, I have 12 items of the Gallup. So if a variable has a single item also, then in that case also PLS-SEM could run. So there's no issue with the number of items with the PLS. Secondly, it incorporates the reflective and the formative measurement model. I'll tell you later that what is formative and what is reflective model. If your model is highly complex, if it has n number of variables, it has n number of items, it could be easily run with the help of the PLS-SEM. It means if you are having n number of hypotheses in your study, or you're trying to take n number of variables with the different items, it could be run with the help of the PLS-SEM. You can easily identify the relationship among those variables with the help of the PLS and the SEM. Model setup, no casual loopholes are allowed when you are using the model. What happened when we prepare, like we have some variables in our dashboard, in our board, we have different variables. And if you have not connected with the arrow, with like if I have one variable, for an example, environment, and I want to connect it with the job satisfaction. If I have not connected the variables with the help of the arrow, it causes as a loophole in the model when we are trying to connect the variables with the help of that particular arrow. If you have not done so, the PLS-SEM will not run or it will not work. So we have to properly put the variables on the dashboard systematically. We have to put the arrows to connect the hypothesis, to provide you the hypothesis. Like if I'm having the variable work environment and I'm trying to connect it with the job satisfaction or with the turnover intention, in that case I have to put the independent variable at the one side and dependent variable on the another side, and I have to give the arrows so that it could connect the x independent variable to the dependent variable. In the case of the mediation, what we do, we have independent variable, we have a mediation, and we have certain dependent variables. We have to make proper connection between the variables on the when we are preparing the model with the help of those arrows. If we are able to do so in a proper way, or if we are able to make a model on the PLS platform in a proper manner, then only the PLS-SEM will run. If we are not able to do so, we are not able to connect the arrows in a systematic manner, it will causes us a loophole and it will not work in the PLS-SEM. So what are the basic objective of PLS-SEM algorithm properties? Objective: to maximize the R values or R square values, to to have different or the few iteration situation model we have in the PLS. Like we can if we suppose we have the data set of 100 respondents and I want to check that particular data on 500, I want to multiply it by 5. What I have to do? I have to do the bootstrapping, I have to do the bind folding, so that it could irritate the data into a 5, 6, 7 steps automatically. Nextly, we have like evaluation of the model. Yeah, no global goodness of fit criteria meets here. Basically, what we do in the MOS, when we are trying to confirm a particular model, when we are trying to confirm accepted or rejecting any particular model, we have to check the goodness of fit. Like my data set is good fit with the model, yes or no. My data set has particular equivalent like fitness with the model, then in that case we have to check the global goodness of fitness criteria. Here in the PLS, we don't have the different methodology to use this goodness of fit, but yes, there are few tests by which we can analyze or we can predict if my data set is goodly fit with the model, yes or no. Suppose I'm having the model Big Five theory model, and I'm on the basis of that I have circulated some questionnaires, and I got the responses from the 100 respondents, and I want to test that particular model on those basis on those particular 100 respondents. In that case, I have to check whether my model is perfectly fit with the 100 respondents, or to make a fitness of that particular model, I need 200 responses, I need 300 responses. To check this particular relationship or to check this particular algorithm, we have to check the global goodness fit criteria, which is not in the PLS-SEM, but yes, there are certain tests which could be applied to check the goodness of fit when we use the PLS-SEM. Okay, in the PLS-SEM, what we have two sort of models. First one is the measurement model, and second one is the structural model. Both model are important to predict, both model are important to analyze, because in the measurement model, what we have, we are trying to measure our model. We are trying to measure it on the basis of the reliability and the validity. We try to measure it on the basis of AVE, that is average variance extracted. We are trying to measure it on the basis of the discriminate validity. What we have in the SPSS, we have reliability and validity check with the help of the Cronbach alpha and the KMO and Bartlett test. What we do, we try to analyze those reliability and the validity with the help of the KMO test, with the help of the Cronbach alpha test. But here we have different tests which predicts more good results, which give us more good result, more concise result, on which we can have we can say, yes, my data is best fit with the model, and my model is, or my model could be tested again by providing some future gaps also. Evaluation of the model. When we try to evaluate the model in the measurement model, we can evaluate the reliability and the validity. In the structural model, we can analyze the path coefficient significance, we can analyze the coefficient of determination, we can analyze the effect size of the model, we can also analyze the predictive relevance, means how much relevant is my model, means how much relevance is there with the help of those variables. Suppose I want to know whether my employees are engaged or not engaged, and I have 4 variables with me. I have first work environment, second one is suppose perceived supervisor support, third one is like communication, and I want to test it with the mediation, that is employee engagement, and the turnover intention as the dependent variable. In that case, what I have to check, I have to check the relevancy of that model. This is what I'm trying to predict, this is what I'm trying to test in my research. So here I have to first evaluate the reliability and the validity of my particular model, then I have to evaluate the the relationship between those models. Then only if the relationship is good, then also I can't say my model is fit. I can only say this when I have good Q value, when I have good R value, means the predictive relevance, that is Q square value of my model is appropriate, then only I could say that yes, my model is quite relevant in the terms of the research. So all these are the characteristics of the PLS-SEM. We can have, there is no issues with the sample size, yes, but there is a threshold rule. There's no issues with the distribution of the data. We can also run the PLS-SEM with the help of the non-normal distributed data. There's no issues with the missing values. But yes, if we want my results to be very accurate, I have to take care of the missing values. The scales of the measurement should be appropriate and ordinarily used. PLS-SEM can use a single item measurement. A single item associated with the variable can be measured with the help of the PLS-SEM. We have 2 types of model in the PLS-SEM, that is measurement model, which helps you to predict the reliability and the validity with the help of the AVE test and with the help of the discriminate validity test. Secondly, we have structural model, by which you can easily analyze the path relationship among the variables which are in the PLS model. Although with these basic characteristics, we can easily evaluate the motivation effect, we can easily evaluate the mediation effect, we can also analyze the multi-group analysis, we can also analyze the hierarchy components model. These are the certain additional analysis which we have with the PLS-SEM, which could be run with a single click in the PLS-SEM software. So rules of this, thumb rule of choosing between the PLS-SEM. But when to use PLS-SEM and when to use CB-SEM. When, as I already told you, when your aim is to identify the key driver construct, or the goal is to predict the new construct or to predict new model, you have to go towards the PLS-SEM. When your goal is to test the particular theory or to compare the particular theory or to confirm the particular theory or the alternative theories, you have to go towards the, or you have to choose CB-SEM, that is covariance-based SEM, which we have in the MOS. Secondly, formatly measured constructs are the part of the structural model. What variables or what variate we put into the dashboard on the PLS-SEM, that could be a part of the structural model, means we have to analyze the relationship among the variables. If we are just checking measurement, like if you are just checking the reliability and validity, then there is no use of using SEM. You can easily use SPSS in that case. But yes, if you are trying to analyze or predict any particular model with the help of the new constructs, or you're trying to develop new theory, then you have to go towards the, or you have to choose PLS-SEM. The sample size is small or the data has the non-normal distribution, you can use PLS-SEM. The plan is to use the latent variable scores in the subsequent analysis. Like you want to do another analysis also, like as I already told you, Q square, R square, predictive relevance, we have mediation effect, we have moderation effect, we have multi-group analysis effect. So if you want to take your data into another, want to run your data with another test also, then you can use the PLS-SEM. When we use CB-SEM, as I already told you, the goal is for theory testing. When you have certain certain specification, when your research requires a global goodness of fit criterion, you want to analyze, yes, this particular model is globally fit, then you have to go towards the CB-SEM, that is covariance based structural equation modeling. Okay, now what are the consideration in using structural equation modeling? Means what are the certain elements which are important when you are running or you're working with the PLS-SEM? First one is the variate, second measurement, third measurement scales, coding, and the data distribution. So let us know what are these certain elements are. The variate, what is variate? Variate are simply our variables that we are put into a research problem. Like if I say I want to check whether the work environment affects the employee engagement, or whether the work environment helps employees to get engaged, it means I have two variate. We have two variables, that is the like work environment, second one is the engagement, and we are trying to combine those variables in and putting it into a particular model. So variate are the linear combination, like numbering, we are providing the numbers, we are giving like I'm giving work environment number one variable, employee engagement number two variable. Secondly, I'm giving work environment items, like if I'm having a single statement, my colleagues are very helpful. Yes, this is the part of the work environment. If I'm having this statement, as so I have to give a number one to that particular variable. I can't write a complete statement when I'm running the PLS-SEM. I have to provide numbers to variables also. I have to provide numbers to the items also, because PLS-SEM read and runs the numeric values. So I have to provide each and everything into a numbers. Secondly, measurement. Measurement is a process by which we are trying to assign numbers to the variable set. The rule are used that numbers should be assigned variables properly, and the data set and that particular model numbering should be matched, should not be mismatched. If it is mismatching, like if I have given the work environment statement number one, then in the model also I have to provide the number one to the work environment first statement. So the numbering should be matched. There should not be mismatch between the numbers which I have provided. Basically, what I try to say here, that numberings are like coding here. So if we are doing coding in a wrong manner, then it will not read the data set, the algorithm will not read the particular thing. Measurement scale. What is the measurement scale? Measurement scale is a tool which predetermine the number of close-ended respondents. Sometimes in the research we take like structural questionnaire, sometimes we take unstructured questionnaire. We try to formulate the questionnaire by our own. So in that case, you have to take a proper, if you are taking the structural scale, you have to take all the items. from the scale. So we have to predetermine the close-ended questions. As I already told you, the PLS-SEM runs on the ordinal data. If you have taken the Likert scale into your consideration, or if you have given numbers to your items, then it could be easily run in the PLS-SEM. We can easily run the PLS algorithm on the basis of those data set. So measurement scale is a tool which determines number of close-ended responses, and the nominal scale is the numbers that we are trying to assign and identify when we are identifying certain objects. What is coding? Assignment of numbers to certain category is the coding. Like in the Likert scale, what we do, strongly agree 5, strongly agree 4. So we try to give numbers. So in PLS also, SEM also, we have to take care of the coding also. We have to properly take care of the coding, what we are trying to code in the data set and what we have coded in the PLS-SEM software. When researchers collect the quantitative data, that is the distribution, we distribute the data on the basis of the demographic, we distribute the data on the basis of the variables we are trying to study in our research. So the distribution of data should be properly be built. Okay, now data consideration. I have told you that we can use small sample size when we are using PLS-SEM, but still there is a rough guideline. There's a rough guideline or threshold guideline when we use PLS-SEM. As a rough idea, if we have the minimum sample size that should be equal to or larger to the 10 times rule. Like suppose if I'm having 5 variables, if I multiply it by 10, so at least 50 respondents I must have in my data set. Then only we can run the PLS-SEM. If I'm having two like construct, if I'm trying to analyze only work environment and the employee engagement, engaging employee, then in that case, minimally I must have the data of 20 people. So this is the minimum criteria. But yes, if you're having good number of data set, if you're having n number of respondents in your data set, that the consistency of your model or the consistency of the results could be at large. Like if you're having 250 plus sample size or the data set, and you're using the same set of data on the PLS-SEM and the CB-SEM, the results are quite similar. What you see, the results are very, very, very similar. When you're applying the same data set on the CB-SEM and applying the same data set on the PLS-SEM, and data should be like larger than the 250 respondents, or variables should be 4 plus. So this is the threshold rule of the CB-SEM and the PLS-SEM. PLS-SEM can handle non-normal data also. PLS-SEM can consider the model complexity also. If you are having if you have met the proper data with the minimum requirement of the data set, then you can easily apply PLS-SEM. So this is just a threshold value which I tried to convey through this particular slide, that data consideration is very important when we use SEM. But yes, if we have good number of data, larger number of data, the consistency of the results will be increased. And if you are having 4 plus variables along with the 250 plus data set, then the results of CB-SEM and PLS-SEM are quite similar. Structural equation modeling with PLS-SEM. Okay, what is path model and the path modeling? Path model is something which we try to draw, draw on the PLS-SEM dashboard. We put different variables. We connect those variables according to the hypothesis which we are trying to study in our research, and we try to make a proper model in the like dashboard. So PLS model is basically a diagram which is used to visualize, or which is used to display the hypothesis among the studied variables which we are trying to study. Like previously I have given an example. If I'm having 2 variables like work environment and the perceived supervisor support, and I'm trying to connect it with the employee engagement, when I'm connecting it with the help of the arrows, then it means I'm trying to make a model. What we do in a rough copy or in a page, we try to draw up a conceptual framework. That conceptual framework I have to make it on a PLS dashboard. What are the constructs? Constructs are the like circles or the ovals which are represented as a path model variables. When we click on the latent variable and we put the latent variable on the dashboard, then it comes with the like in the shape of the oval. We have to rename it. In the next session, hopefully I will be able to provide you some hands-on experience on the PLS-SEM, of course, and I will let you know how to make a proper path model, how to connect the X variable with the Y variable, how to analyze, how to run the PLS-SEM, and how to interpret the research results. What are the indicators? Indicators are the items which indicates the variables. Like if for the employee engagement, I'm using Gallup questionnaire and I'm having 12 items. So indicators means indicating the items which is associated with the variable. So we have indicators also. In the PLS, we have arrows also, which are used to provide a directional relationship. Like we have a positive relationship, or we are having the negative relationship, or we are the items are predicting the constructs, or the constructs are predicting the items. So we have arrows to predict the model. Here you can see these are the constructs like work environment. You can take an example. This is like work environment. This is like perceived supervisor support, and it is connecting to the another variables. So these ovals are the variables or the constructs, and these boxes are the items which we can say are the statements also, like X1 statement, X2 statement, X3 statements. So the responses of these three statements are predicting this particular variable. So this is also known as exogenous latent variables. When the arrows are connecting towards the constraint, it means these particular items are predicting the particular construct. Here you can see there's a difference of the arrows, the direction of the arrows. It means the construct is predicting the items. Here the items are predicting the construct. Here the constructs variables are predicting the items. So there's a difference when we make a model. When we put the arrows like this in a right direction, it means the items are predicting the construct. If we are providing the arrows in the another direction, it means the construct is predicting the particular variable. So this is like a model, just an example which we try to make on a PLS-SEM software. As I already told you, we have two sort of models, measurement models, and second one is the structural model. What measurement model do or measurement theory do is specify how the latent variables are measured. For an example, in this slide, you can see this is the variable X, suppose 1, this is the variable 2. So what we try to analyze with the help of the measurement model, we are trying to analyze how much strength the X1 variable item has with the Y1, how much strength the X2 item has with the Y1, how much X3 item has the strength with the Y1. Suppose if I'm having the values like below 0.7, and second value is coming like 0.5, third value is coming like 0.2. It means the third value has a weak relationship with this particular construct. If I try to remove it, the loadings will distributed among 2 only. Now, if I remove the X3, it means the loading will be distributed among the 2 only. So the strength of X1 and X2 will increase. So with the help of the PLS-SEM, we try to provide a predictive relevance to our model, and we can do it with the help of certain variables which are in the oval and certain items. So measurement model help us to measure or to evaluate the strength of a particular model, like how much these indicators are having strength, how much strength they are providing to a particular construct. So this we can easily be analyzed with the help of the measurement model or the measurement theory. So measurement theory specify how the latent variables are measured. We have two type of measurement model. First one is reflective. As I already told you, the direction of the arrows specifies the relationship between among the hypothesis. Whatever hypothesis we have created, we have to provide an arrow that could be defined our hypothesis in a proper manner. So arrow is the like main indicators which helps to us to know either my model is reflective or my model is the formative. Reflective when the construct to the when the arrows are from the construct to the indicators, and formative when the indicators defining the construct. So basically, we in the measurement model we have two measurement models: reflective and the formative. Structural theory. Structural theory basically defines how my variables has the relationship. Basically, it shows the relationship between the construct. It helps us to know whether my hypothesis is accepted or rejected. For an example, I have same example I'm giving here. I have one work environment. I'm having employee engagement. Work environment are measured by the 4 item. Employee engagement is measured by the 12 items. Suppose when I have the responses, the last item of my construct, that is the last question of my construct, is weak. The results are coming weak. If I remove that particular 12th item from my model, the strength will be distributed among another 11 variables. Same with the work environment also. So this could be easily being measured with the help of the measurement model, like our indicator strength, our indicators loadings, our items loading, our reliability, validity, which it could be measured by the measurement model. Means how much strength my model has in the terms of the indicators, in the terms of the items, and in the terms of the variable being studied in as a path model. But yes, structural model, after analyzing the reliability, validity of my model, it means yes, my data set is being good fit with the data or like model. We move towards the structural theory. That means now there's a point where we are trying to analyze whether the x variable has certain relationship with the y variable, or the x variable has some impact on the y variable. So for that purpose, we have to run the data set into a structural model, and it helps us to know the relationship among the x and the y variables. So this is the stage where we try to like accept or reject our hypothesis. After that, we are trying to predict the relevancy of our model as a combined model. Here, what we are trying to do, we are trying to just take a variable and we have certain items. We are trying to analyze the relationship between the items and the variables, and the variables x with the y variables. We are not predicting the the relevancy of the model. But yes, if I want to predict the relevancy, I have another test, which I'll definitely tell you in the next session. First step in the basic step in the PLS-SEM is to prepare a diagram in an appropriate manner and to illustrate the research hypothesis, and to display the relationship which we are trying to explain. Like this is the work environment variable 1. Here is the engagement as a mediating model, and here is the job satisfaction as the dependent model. So what we are trying to do, we are trying to analyze the relationship of work environment with the engagement, and engagement with the job satisfaction, and engaged work environment with the job satisfaction if I considered employee engagement or the engagement as the mediator. So we can exchange the relationship also. We can analyze the mediation moderation also with the help of the PLS-SEM. These are some basic guidelines for preparing the PLS-SEM model. First of all, we must have proper constructs or the variables which we are trying to study in our research. Secondly, the measurement description. What are the endogenous and what is the exogenous? Means whether we are moving towards the reflective model or we are moving towards the formative model. We have to determine it in an initial stage. If apply, we can easily apply complex relationship, like we can easily evaluate mediators, moderators with the help of the PLS-SEM. There should be a proper conceptual framework. Means your hypothesis should be clearly illustrated, should be properly defined, that what you are trying to evaluate, which variable you are trying to evaluate with what variable, like what are the certain x variables which you are trying to evaluate with the y variables. Measurement discussion should state the first in order. Yes, of course, you have to make a model which how you're trying to predict. Like if you want to predict the work environment and of initial stage, secondly you have to you want to evaluate the perceived supervisor in this second stage, you have to put your ovals, you have to put your construct in a systematic manner, in which manner you're trying to evaluate. If you want to evaluate the relationship between x and the y variable, you have to provide those particular construct in a initial stage. The measurement perspective, that is reflective and the formative, should be clearly stated, and the concept of your model, like what you are trying to evaluate, what is the aim behind your study, should be properly been like framed before you are using PLS-SEM. Thank you so much.
Hello.
Yeah, thank you so much. Any queries or doubts from the audience?
Thank you so much, ma'am. Thank you so much for this very nice session. If anyone has any question, you can ask. I think no one have any question, ma'am. Thank you so much, all the participants, for your active participation. Let me inform to all that this complete session available on our Research Circle YouTube channel. So if you want to watch it again or want to share it to somebody, please do visit the Research Circle YouTube channel. Thanks. And last but not the least, thank you, Dr. Muskan Khan ma'am, for taking out time for session. With your permission, I would like to end today's session here. Thank you.